From the part regarding the introduction to atomic structure, you know that the atoms and molecules is very small. So, how these atoms and molecules transform to material that you can see and we can touch, and not only that, we can alter the material in order to form products. Formation of matter or material is from the interaction of atoms. So you have atom A and you have atom B. So this atom can be the same atom or different atom. So at the beginning, this atom is far from each other. So it is in the infinite separation. However, in order to form a material out of it, these two atoms should be brought into close proximity. So, when these two atoms come closer to each other, there are two forces is going to act on the atom. One is the attractive forces and repulsive forces. Okay, and it depends on the separation or interatomic distance between the atoms. So it depends to the R value. So, the origin of the attraction between the atom is definitely based on the type of bonding that can exist between the two atoms. Okay, so here, you have to note that the atoms itself going to affect whether there are strong or weak attraction between the two atoms. So, as the atoms approaching each other, ultimately, it's going to reach the region when the atoms begin to overlap and a strong repulsive forces comes into play. So attractive forces will act first, and then when it becomes closer together, then they're going to be repulsive forces. And then it's going to reach where the net force, the Fn, between the two atoms, where Fa is equal to Fr. So all of this is going to be the function of the interatomic separation. When the atoms become closer together and it reaches the point where attractive forces equal to the repulsive force, the net force is going to equal to 0. And at this particular moment, we said that it reached the equilibrium state. Okay, so the equilibrium state where the R is equal to R naught. As you can see here in this graph, okay, this is where the two atoms is far between each other, is at the infinite region, and as it closes together, the attractive forces increases, and it's going to reach the point where the repulsive is start to act on the atom, and it's going to reach the region of equilibrium here when the R is equal to R naught. So the center of the two atoms will remain separated by the equilibrium spacing R naught, and most of the atoms having R naught equal to about 0.3 nanometer. So at this point, the atom will counteract any attempt to separate them by an attractive force or to push them together by an repulsive action. So this is where, when we describe this interaction based on the forces acting on the atom. So in some cases, it is easier, more convenient if we explain in terms of the energy and forces. Energy is the function of work when the atom is approaching each other, whether it's involved in the positive or negative work due to the attraction and the repulsive forces at certain distance. Okay, so the E net can be simplified to be the energy of attraction plus the energy of repulsion. So when it reaches the R naught, the equilibrium region or the equilibrium state, the net energy there is referred as the bonding energy. Okay, so this bonding energy, the energy required to separate these two atoms to an infinite separation. So it is the energy needed for the bonding to form, and it is also the energy needed to separate the atom. So this is the graph of the energy relation with the interatomic separation, and you see here this is the net energy, which is equal to the bonding energy. the atomic bonding between atoms is going to affect the properties that we're going to achieve. So even the magnitude of bonding energy in knot and the shape of the energy versus interatomic separation, which is E versus R, as in the previous slide, vary from material to material. So each material has different bonding energy as well as the energy versus interatomic separation behavior. So even this both is also depends on the type of atomic bonding that can be formed between the atoms. So this E-note curve of the shape and the bonding type is the factors that can affect the material properties. So because the properties has always become the focus of engineer. So you see, even by observing the behavior of atom interaction due to the formation of bonding from previous energy versus interatomic distance, we can postulate the thermal properties, physical properties, as well as the mechanical properties. So you see, materials having large bonding energy typically have high melting temperature because it is hard to form the bonding between two atoms. It needs more energy. So when you want to break the bond between these two atoms, you also need more energy to separate it. First is in terms of the melting temperature. The second is in terms of the coefficient of thermal expansion, how easy the material to expand with heat. So it depends on the E-note versus R-note curve. So you see here, it mentioned that the deep and narrow trough correlates with the low coefficient of thermal expansion. So you can observe here, okay, E-note versus R-note. If the trough here is narrow and deep, it is mostly belongs to the low coefficient thermal expansion material. Then we can also expect the effect of this atomic bonding in terms of the physical form. For the solid substances, normally it involves large E-note, whereas to form gaseous state material, you just need low E-note. However, for the liquid, you just need the value of E-note at the intermediate magnitude. The third, this is one thermal physical form. Third is the mechanical properties. So you can predict the mechanical properties of a material also from looking at the force versus R separation curve. Okay, it mentioned here that the slope at the R equal to R node position, if actually it's quite steep, it belongs to the stiff material. If the slope is shallower, it belongs to the flexible material. So you see here at this point, if this curve exhibits steep slope or shallower, you can determine whether the material is stiff or the material is flexible. So you see, because this one also related to the bonding energy, if it needs more energy, it becomes steeper, okay, because this one, the trough become narrower. So the material mostly stiff. But if you just need low E-note, okay, here, the slope will become shallower. So it mostly belongs to the material which is flexible. There are a lot of atoms which when you do the electronic configuration, they are energy state or the orbitals that not filled up by the electron. So it means that this electron configuration, it is not stable because the orbitals still need to be filled up by electrons. So because of that, the outer shell is not fully complete. So the outer shell can be considered as the valence shell. The electrons that occupy the valence shell or the outermost shell, we know as the valence electrons. It fill up the shell which are not stable and which is not reach the octet. So this electron can participate in the bonding between the atoms to form atomic and molecular aggregates. Previously, I mentioned to you that we have atoms, right? So when this atom plus another atom to form molecule is going to form clusters of atoms or molecules, and it can later on growing become aggregates to form bulk material. So say for example here we have carbon atom. So you know from the periodic table the carbon atom have atomic number of Z. So Z is the number of proton as well as the number of electron for neutral atom, right? So when it has 6 atoms, it means that it's going to fill out one S2 orbital first and then followed with 2 S2, 2 P2. But you remember that for the P subshell, it has 3 energy states. So when you only have 2 electrons, it still has empty state to fill up with electron. So it needs another 4 electrons for the atom to reach octet. Okay, whether or not the material has low number of electrons needed for it to reach the octet, it depends to the atomic number of the atom. So if the atom has high number of electron valence, definitely the tendency for the atom is to accept electron because it just only needs several locations to fill up with atom. However, for the atom that having low number of electron valence, so it is has potential or tendency to give up the electron. So the tendency for the atom to attract electrons from another atom is called electronegativity. Talking about when you want to form the material or matter from atoms, there are two types of forces that act on the atoms and molecules. Okay, one is called intramolecular forces, which is going to give the intramolecular bonding. So this forces is the force that kept molecules together within the molecule. So you have this atom A, you have this atom B. So to form this molecule, you have intramolecular bonding. Okay. The second one is intermolecular forces from the intermolecular bonding. So it's the attractive forces between molecules which are responsible for keeping in their form, whether it is the solid or liquid phases. Okay. So you see here you have the molecule. Okay, and it forms larger molecule here, and this is the similar larger molecule. So between this molecule there are secondary forces between it, and this one we call it the intermolecular forces that form the intermolecular bonding between the molecules. About the intramolecular bonding, or we call it the primary bonding, that bond together the atoms within the molecule. We have three types of this bonding, which is one is we call it ionic bonding, another one we call the covalent bonding, and third one we have the metallic bonding. However, for the intermolecular bonding, it's actually between the molecule. When we have the secondary bonding, or we call it van der Waals bonding. So we can find van der Waals bonding between the molecules. One, we have fluctuating induced dipole, polar induced dipole, or permanent dipole. For example, hydrogen bonding. So ionic bonding is due to the strong column interaction where you have positive and negative charges between atoms. Whereas for the covalent bonding, the key point is electron shared between the molecules. The atoms share their electrons together to form the covalent bonding. Meanwhile, metallic bonding is formed between the metal atoms, where the key point is the electron from the electron P. Okay.